So the T sound, it gives a single high frequency burst. If I'm going like that, what happens is a noise burst at the frequency of the second formant of the following vowel is heard as a K. A noise burst below the second formant is heard as a P. So for example, if I say cow versus pow, how does the brain distinguish it? And so here's sort of how that works. For the K sound versus the P sound, even though I'm using the same formant pattern, for example, if the brain hears a cow, there's a little separate burst above the second formant that represents the K. However, if it hears a pow, your brain hears this little burst of frequency below the first formant, or right around in there. So that's how the brain sort of represents it. Now, in addition, there are visual cues that you can get, because if you're just listening to an audio recording, that's all well and good, but let's say you're watching someone speak. And what does the brain do if someone says cow, but you see the lips do that plosive? And as it turns out, the brain has become so visual with reading the lips that if I take someone saying the word pow, pow, pow on an audio recording and have a video of a man saying cow, 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 or vice versa, let's say I have someone saying cow, cow, cow in an audio recording, have a video of a man saying pow, 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 and you see those lips closing and opening. If I remove the video audio and replace it with cow, remove the pow from the video, replace it with cow, and so as you see the man saying pow, 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 you're hearing the word cow, 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 your brain is totally fooled by that. You will hear pow, 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 because you're seeing the lips make the shape of a P. So even though we can do this in an audio recording, and the brain has if the brain has visual cues, then it'll replace that and say that was obviously supposed to have been a P. It'll make that shift, and you'll hear pow, 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 even though when you close your eyes, you'll hear cow, cow, cow. Isn't that weird? There are videos online where you can take a look. I won't bring one up right now. Might take a look at that here in a few minutes. Just replacement of speech. So there's so much more going on in the brain than is going on in just your speech recognition software on your phone. So another thing is the relative change of frequency as you moved into one of these into vocalizing a vowel after a consonant. So there's really sort of this in-depth graph on page 361 that you're going to need to use. Actually, it's easier to kind of break that down. It's broken down on the next page. But on 361, what we're seeing here is the word T. And as they say that word T, they're going into different vowel sounds. T, 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 ta, 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 tu, 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 tu. And so what happens is that that T sound, it always originates in the same place. But yet, those formants that follow, and I think this is the second formant that's graphed on page 361, figure 16.7. That second formant is going to be at a different location depending on the vowels. We've already seen how that works. So it'll either be rising up from the T sound, or it'll be right at the same frequency as the T sound, or it's going to be dropping down for the T sound. And actually there's a little bit of a silent interval that happens, so we don't actually see the convergence of those frequencies. So if I were just to isolate one of these, and I can do that by turning to the next page, and not T, but they've got 3 examples starting with a B, or a D, or a G. And so let's take a look at what happens with the second interval. So let's examine just the first one. Just that first one up there. So he has frequencies on the left side ranging from 600, and I don't want to do the same. Okay, your book does the consonant D. Let's analyze B and sort of see how that works without doing the same problem that you find in your book. Okay. All right. So what this is, let me draw this out. It takes a little bit of explanation here in order to sort of get what's happening. And let's look at the second formant. So the second formant, B, and the B sound is kind of a low frequency sound. Okay? And for the most part, it's going to be lower than the second formant. And if I were to draw this B sound, B originates here. Let's say it originates there. But it takes a bit of a silent interval before that. So even though B originates there, by the time I voice it, I've got a little bit of a silence in there between. And so I'm going to draw a dash line starting off, but then here comes the B. And maybe this is B. And this is second formant. But then I might say ba. Again, I got a silent interval there, and ba. Maybe I might say ba, boo, or let's say ba. And I've got this, or maybe somewhere in between there I might say be. Just to give me another one here. Silent interval, and then it rises into, and then it straightens out. You've got this little be valley here. So right there is a silent interval from here to the locus point of the B sound. And you see I've got, if I'm imaging this, I'm going to have this rise up into the sound. Now, it may be most instructive if I put 2 of these letters on top of each other, okay? I know I've got 3 graphs. Let me stack 2 on top of each other. Let's say that I'm going to say these 3 same vowel sounds. E, A. And this represents the location of the second formant. As I begin to do that, it's dropping in frequency. But this time I'm going to use G. And when I do that, the G sound has a locus that's up here. So our B sounds originate lower. I'm pushing a lot of air. I've got my lips closed. I put air pressure against the back of my lips. I open my lips and I get this poof sound. If I'm talking into a microphone, recording engineers hate the letter P and they don't like the letter B, because what it gets this sound of the microphone of the air hitting it, and that's this low frequency boom. That you have to put up a windscreen and everything like that to protect your recording from puffs of air at the word P. But is this similar? P is going to be originating even lower. But let's look at G, which is almost a sh sound. It's very fricative, and it's going to have a locus that's higher. We still get this silent interval, but then it would look like this for ja or ga. It would maybe look like this coming into the a vowel. It would look sort of like this coming into the e vowel. So by the time you reach the transition period, You've got transition, you've got silence, and then you've got vowel. So the transition period is what gives us clues as to what consonant was spoken before you reach this long vowel sound where the original consonant by this time is long forgotten. You're just hearing you don't know if it was ba or pa or ga. All right, so here's the transition. You can be rising into it, which the brain says it's not a huge rise, so it's not a pa. This must be maybe it's a ba. Okay, so you're getting your decoder is getting clues. You get this shift downward. Maybe it's ga, ja, J sound or something. So let's take a look at those shifts. Now it's not just showing us two formats. One format it's showing us two, and it shows a different rise from the. And this is just looking at the second format. Second format might be dropping. First format is going to be could be rising. Okay, because wherever it's located when it gets that low frequency, what's